In this section, we're going to cover 2.5, an introduction to quadratic equations. There's a lot of information in this section, and it is worth spending a decent amount of time on. Quadratic functions are going to be one of the most important parts of college algebra, so I really encourage you to take your time with this material and really solidify your understanding. Okay. We're going to start with solving a quadratic with factoring where the leading coefficient is a 1. So that means this right here has a leading coefficient of 1. We know that if there's no number in front of a variable, it's assumed to be a 1. The same thing for here or here even. Okay. So I use the grouping method usually. If the value is a 1, you don't have to use the grouping method. You can just go straight into factoring. And so what's going to happen is you are looking to add up to your B term and you want to multiply to C or AC technically, but A is 1. And remember that for quadratics, your standard form looks like this. So when I say A and C, here is A, B, and C. So if I'm adding up to B, I'm interested in adding up to 5. And if I'm interested in multiplying to AC, I want to multiply to 6. I always make a table of values, even if it feels silly. Here are all of my factors of 6, 1, 6, and 2, 3. And I immediately notice that the only one that makes sense is 2, 3. That's going to add up and get me 5. So I'm going to go ahead and write x plus 2 and x plus 3 equals 0. If I'm solving, I'm going to go ahead and set each one separately equal to 0 and go ahead and get my answers of -2 and -3. Okay, that's factoring. We have a similar situation here. Now we're interested in adding up to -1 and multiplying to -56. So again, making a table of values, 1, 56, yada, 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 I'm going to end up at 7 and 8, okay? Notice that these are both negative, so I really want a -1. So I'm going to make the 8 negative and the 7 positive. That's still going to get me a -56, and it's going to go ahead and get me that -1 that I need. So now I'm going to write x plus 7, x minus 8 equals 0. Set each one separately equal to 0 to solve. And then I get -7 and +8 as my solutions. So the first line in green was factoring. The boxed answer is the solution from factoring. Let's go ahead and do one more. Okay, so now we're interested in adding up to 4 and multiplying to 8. So let me go ahead and make my table of values. Okay, these are my only options for multiples of 8. Multiplying to 8. And you'll notice that neither of them work. So this is not factorable using this method. Okay, so not factorable with current method. We can end up factoring with a quadratic formula later, and we will, but I'm going to stop there for now. Okay, now let's talk about what zeros, solutions, x-intercepts, and roots are. They're all the same thing, okay? They are where we cross the x-axis on a quadratic, okay? We can graph the quadratic. We call it a parabola, but it's all the same, okay? So we are interested in multiplying to -6 and adding up to -1. So making my table of values similar to earlier, the only difference being, again, this is negative, so I want -3 plus 2. So x plus 2, x minus 3 equals 0. So my x-intercepts are going to be these values, okay? If I come over here onto my graph, oops, that just deleted. If I let me rewrite this really briefly. X plus 2, x minus 3, x equals negative 2, x equals 3. If I come over here to my graph, I can plot those points, okay, and those are my x-intercepts. That's not enough information to graph yet, but let's see what else we've got. I'm going to go ahead and rewrite my table. Okay, we also have the y-intercept right in front of us, okay? Our y-intercept is negative 6, okay? When x is 0, all we're left with is negative 6. So that is my y-intercept. That would be helpful to graph as well. So let me go ahead and drop down over here. 1, 2, 3, 4. Yep, so that's that. Okay. So I don't have enough information to really get an idea of the curve. I do want to point out that this is not necessarily the lowest point. I know that it's not going to be, so I'm going to go ahead and graph it, keeping in mind that this is going to be my lowest point, somewhere over here. Okay, that is not exact, and that's okay for right now. But a quadratic is a U-shaped curve. We can also call it a parabola. And it is important to know that the y-intercept is not necessarily the lowest point. All right, let's talk about solving different kind of quadratics. We can use the zero product property, okay? That just means it's a difference of squares. So if you look at that number, you know that it's a perfect square. That means square root of 9 is plus minus 3, or square root of 4 is plus minus 2. That's what this is saying. So if you have a difference of squares, you can skip all the way to this point without having to do much else. You have a positive version of the answer, and you have a negative version of the answer. Boom, done. This will work for any difference of squares. The square root property is where you solve for x by taking a square root. So if I were to bring this 9 over and take a square root, okay, by doing this, I'm removing the square by adding a square root, okay? This is the square root property. You end up with the same answer, plus minus 3. There's always two solutions to a root because there's two ways to get a number, a negative times itself or a positive number times itself. Let's look at this next section. We can solve either of the two ways we just did. The square root of 1 is 1, so we could just go ahead and do the square root property or the difference of squares. So x equals 1 or x equals negative 1. B is the same thing. I'm going to go ahead and use difference of squares because this is a perfect square and so is this. So I can go ahead and say 2x plus 5 and 2x minus 5 equals 0, which means when I solve, I have plus minus 5 halves. The last one, I think we need to use the square root property because this is not perfect. Not perfect. Okay. So let's go ahead and bring that over by adding and then divide by 2. Now it's perfect, which is great. And we end up with x equals plus minus 4. All right. Standard form, I briefly mentioned at the very beginning when we started factoring, okay? Here is standard form. It is useful. A, B, and C are all real numbers. To find the x-intercepts, we need to set y equal to 0 and solve. So for x-intercepts, y equals 0 and solve. For y-intercept, it's the opposite. X equals 0 and solve. Okay. This is, yes, the zeros of a quadratic are always x-intercept. They are the same, unless they are not real. Okay, unless they are imaginary, which means you have a negative root. Imaginary. And we don't really cover that in this class. You'll cover it in pre-cal if you move on to pre-cal, if this is not your only math class. Okay, let's do some factoring when a lead coefficient is not 1. So this is what we call grouping. I think grouping is a great way to solve these. So we're going to start with adding up to b and multiplying to ac. So it'll be 7 and 12. Making the same table of values as earlier, we find that 3, 4 is our best option. So now instead of going straight into those parentheses we did earlier, I'm going to go ahead and rewrite the beginning and the end and replace the middle with my two terms that I've chosen. And this is why we call it grouping. I'm going to split it down the middle. I'm going to factor what the left side has in common, factor what the right side has in common. Notice that they both share this x plus 2. So that's going to get brought down as one of your parentheses, and the other one will be 2x plus 3 from here. Those get brought together. Now we're going to solve, and these are going to be your x-intercepts. Let's do that again with these next few problems. Okay. So we are adding to 10 and multiplying to 21. So 1 times 21 and 3 times 7 would be a good starting point. So it looks like I'm going to do 3 and 7. Hold on, let me switch colors. I'm tired of looking at the same 3 colors here. So I'll go ahead and write 3x squared plus 3x plus 7x plus 7 equals 0. Split it down the middle. Factor what the left has in common. Factor what the right has in common. Bring down the outside. Bring down one of the insides. And solve. So those are going to be your solutions. We'll do that again with this next question. Okay, we want to add up to negative 21, multiply to positive 20. Okay, so we have 1, 20, 2, 10, 4, and 5. Do keep in mind that this time only b is negative, which means both of our terms will also be negative. That leads me to find this as my solution, and I will go ahead and plug that in. So 4x squared minus x minus 20x plus 5 equals 0. Okay, similar to before, I'm going to cut this down the middle. Okay, I'm going to factor out what those have in common. They only have an x in common. And I'll go ahead and factor out what these have in common, also just a negative 5. X minus 5 gets brought down, 4x minus 1 gets brought down, and I'm going to go ahead and solve. We get 5 and 1/4. All right. Looks like we have 2 more to do here. In this one, we are adding up to 4, multiplying to negative 60. Okay, I'm going to go ahead and make my table. We have 160, 230, 320, and then 610 is one that immediately sticks out to me. I'm thinking about this one right here, right? If I make that a minus, that would get me what I need. So I'll go ahead and plug everything in there. So 5x squared plus 10x minus 6x minus 12 equals 0. Split it down the middle. Take out what the left has in common. Take out what the right has in common. Go ahead and bring the outsides together. Bring down one of the things from the middle and solve. Okay, there's your solution for that one. Our last one, we are multiplying to 2 and adding to 3. So our only option is 1 and 2. So we have 2x squared plus 2x plus x plus 1 equals 0. I'm going to go ahead and take out what they have in common. Not much on the right side, just a 1. So we have 2x plus 1 times x plus 1 equals 0, or x equals negative a half, and x equals negative 1. Another method of solving quadratics and working with quadratics is what we call completing the square. This is something that comes back later at the very end of the semester in circles. So I'll go ahead and introduce it here, but we mostly use it for finding the vertex. That's really the most useful purpose for it. Okay. Let me make sure. Yep. Okay. So what you're going to end up doing is you need to create a perfect square. So we'll go ahead and leave the first two terms, but we're going to move the next term over. Okay. And then we want to take half of b. So half of 6 is going to be 3. Okay. That creates a perfect square. And then if we look at this and say 3 squared, that's going to be 9. We're adding it on the left, so we also want to add it on the right. And then we end up with 8 on this side. So really what this form tells you is the vertex. Okay, and this problem is wanting you to solve for x, which is fine, but I just want to make it clear that this is the most useful version of this process, like getting the vertex. That's what this is really useful for. Now, if we want to solve, I'll come over here. If we want to solve, we'll go ahead and take a square root of 8 and subtract the 3. Root 8 can simplify a little bit. I'm not too worried about simplifying, but if you want to, it could be either of these answers. Okay. Either one works for me. Okay. So we'll do that a couple more times here just to practice it. Hold on, I'm looking for my cursor here. Give me just a moment. There it is. Switch colors here. All right, let's do that again. So we have x squared minus 4x plus something equals 6 plus something. We'll take half of b. That's going to be negative 2, and negative 2 squared is 4. So we'll end up with 10. We'll take the square root of 10, and then we will add 2, and we'll have 2 plus or minus square root of 10. And we would really leave these as is. We don't really need to take the square root of 10. Um, Leaving that root is our final answer. Okay. In these guys, we usually want to divide everything by 2 so that our a term is a 1. So we're going to go ahead and say x squared minus 3 halves x minus 5 halves equals 0. Not ideal, but doable. Okay. So we'll have x squared minus 3 halves x plus something equals 5 halves plus something. We're going to go ahead and take half of b, so that's going to be negative 3/4 squared. And 3/4 squared will be 9/16. 9, actually, I'm just going to use that as a fraction bar. 9/16. Okay. So that is going to be, we have to get some common denominators here. Just keep that in mind. Um, Let me come over here really quick. So I'm going to have to make this other one a denominator of 16. So that'll be 40 plus 9/16. Just keep that in mind. So that'll be 49/16. Let me switch back to the color I was using. So now we have x minus 3/4 equals the square root of 49/16. Both of those are perfect squares, which is really great for us. So we have x equals 3/4 plus or minus 7/4, which leads us to 2 solutions. We're going to end up with 10/4, whoops, and we're going to end up with -1. So sometimes they might look complicated in the beginning, but end up being pretty nicely solvable. And then finally, we have the quadratic formula. The good news is, folks, that this will always work. It might just take a little bit more time. Okay, A, B, and C again come from standard form. We've now talked about it quite a few times. Notice that A is going to be the problem from the very beginning that we weren't initially able to solve. Now we're just going to use the quadratic formula and we're going to get an imaginary number. I'm just going to show you that that happens, and then we won't really worry about it from there. Okay, so we have negative b plus or minus b squared minus 4ac all over 2a is equal to x. So let's plug it in. We have negative 4 plus or minus 4 squared minus 4 times 1 times 8 all over 2 times 1. I'm going to go ahead and simplify the inside of that root. That's going to be 16 minus 32, which is negative 16 over 2. This negative 16 tells us that our solution is complex, and we will have an imaginary number. So for our class, we pretty much go ahead and say there's no solution. Okay. The next one does have a solution, so we'll go ahead and take a look at that one. It's also factorable in other methods if you were to factor it that way, but I do want to just show you what this might look like. So keep in mind it was negative b plus or minus, and b is already negative. So I'm going to show that with a double negative just so that you remember when you're doing this to include that negative. Times 1 times 16. I also recommend putting anything that's negative in parentheses, like that negative 8 squared. That is pretty important. you want to make sure that you're accounting for the fact that that is a negative number being squared and not just the 8 being squared with a negative attached to it. Okay, so this is actually going to be the square root of 0 over 2. So all we end up with is 8 over 2, which is 4. So you only have one solution, and that can happen, and that's totally fine. Let's do our last one here. Negative b plus or minus, oops, apologies, where did we go? There we are. Square root b squared minus 4ac all over 2a. Okay, so it looks like we have negative 2 plus or minus 4 plus 36. Okay, so you could simplify this and you could say negative 2 plus or minus 2 root 10 over 2, which would then simplify down to negative 1 plus or minus root 10. I usually leave my solutions like this. If you want to get an approximation, you can. It would be about 2.6 and negative 4.16. Either option is fine. I tend to stick with my roots. All right, let's do one of these last few questions here. A person has a garden that has a length 10 feet longer than the width. Set up a quadratic equation to find the dimensions of the garden if the area is 119 square feet. So we know that length is 10 more than the width. We know that area is length times width. So we are just going to go ahead and replace length with 10 plus W. We also know that our area is 119. So that last row is going to be my quadratic. Okay, so I'll go ahead and expand it. I'll have 10W plus W squared, or W squared plus 10W minus 119 equals 0. This would be standard form. Any of those options work in this problem. I just want to show you how those differ. Okay. Then it asks us what the dimensions of the garden are. So now we're actually going to find our x-intercepts. So this would be an option where you could factor with quadratic formula. So I'll just go ahead and plug that in. Negative b plus minus square root b squared minus 4ac. Okay, all over 2a. Let's see, negative 10 plus minus, let me do some math really quick here, 119 times 4 plus 100 is 576, all divided by 2. I end up with let's see, a width of 7 when solving this. And then when I find length, plugging it back in, I get 17. All right, that covers it for section 2.5, Introduction to Quadratics.